Alright, welcome back to the channel. This video, we're going to build the production-ready app on AWS. The previous video, I gave you a working example on AWS. We relied on a lot of the default things that AWS provides us instead of doing everything in a production-ready sense. We use S3 with unencrypted environment variables instead of using something like SSM Parameter Store, which we're going to use. We did no networking setup. We relied on everything by default. We're going to do all the networking setup and correctly put our ECS service in the private subnets in this video. So we'll see all that in this video as we go along. Now, if you've been following along, you already have the code, but real quick, you can go to the repo right here. It's going to be in the description below, and you just clone it. Git clone, paste the URL, and then you got the code. Great. Open up in your favorite code editor. I'm going to use Visual Studio Code. You can use whatever you want. And we're going to look at a few of the files real quick, and then we're going to dive into AWS and start building the networking setup. Real quick before we get started though, you help me out a lot, real quick, doing a few things. Subscribe to the channel, real easy. Liking this video, sharing on platforms you use like Reddit, LinkedIn, etc. Starting the repo right here on GitHub. You can follow me on GitHub as well, really appreciate that. And I'm already signed in, but if you see this, you can click follow right here. That'd be great. And the last thing is you can either sponsor me on GitHub sponsors by clicking it right here, or scrolling down and sponsor me on Patreon, one time or recurring. Any of that and all of that would be very appreciative. I make no money off this right now. I'd really appreciate it. So with that being said, let's get going. Real quick, the code. The only thing I really want to go through right now before we start getting to the ECS services, because first we're just going to build a networking setup, is these prefixes right here. What are all these? These are all prefixes for the repository names, the ECR repositories, the clusters, the task definition, the containers within the task definition, etc. These are all predefined names. Why do I want you to use these? Because in the following videos, we're going to use something called GitHub Actions to do continuous deployment, CD, as commonly referred to in the industry. We're going to use this to automate updates to our application from GitHub Actions rather than having to rebuild Docker images manually and upload them and redeploy the service. We're going to do all of it with no touch. So for that to work though, we have to have the same names here to be able to reference on AWS. So if you don't want to follow along with these names and use your own, that's fine. Just be aware that in the next following videos, you may run into some issues. That's why I highly recommend using the names as I've defined here. In this file, .github, workflows, aws ecs-deploy.yml. That's where you can find the file to reference these values, and that's what we're going to reference as we go through this video to create the components. Okay, with that being said, we can go ahead and go to AWS. Now, right now, we're going to create the networking setup for our app. So the first thing you want to do is go to the console and you want to search for VPC. Right there, load it up. Here's our VPC console. So we're going to create now our VPC, which stands for Virtual Private Cloud. I am going to be very descriptive in this video with each of the components I create. If you're already familiar with AWS and you find this a little annoying or a little slow, I'm sorry, but I want to make sure everyone can follow along. So with that being said, let's create it. Let's just create the VPC to start. Name tag. We're just going to use this prefix right here. We don't have to specify any of the networking components in the GitHub action file, this aws-ecs-deploy.yml file. We don't do it here because we're not going to be updating these when we update our app. We create them once and then they're static, unless we want to manually make changes to them, which we probably won't unless some new use case arises. But for app features, app updates, these are going to happen much more frequently. That's why we just find out things here so we can update them automatically. But for the networking components, it's just not going to happen a lot. So we don't define them here. But we are going to use the same prefix just because this helps us make it easier to identify the components of our app when we have our AWS Management Console, because we might have multiple apps, multiple VPCs. This simplifies things and makes it easier to identify rather than having you look at random URI strings or whatever. So that being said, here's our name tag, the CIDR. We're just going to use the default one they recommend. Scrolling down, nothing else to configure. Create VPC. Great, we got our VPC. Now, one thing the VPC provides us when it's created is a security group. Now, we're not going to do anything right now. We're actually going to see how we have to modify it at the end, but try to think why, when we're watching this video, if we didn't modify the security group, why we might run into issues. I'm going to show you at the end why we have to. So with that being said, now let's move on to the subnets. So for this video, we're going to create 2 public subnets and 1 private subnet. So let's select our VPC, the one we just created. Scroll down. Same prefix we have already from that file. I'm just going to call it subnet public -1. Availability zone, we'll do US East 1A. For the CIDR block, we use the recommended 10.0.0.0/28. Great. We're going to create two more. We'll copy the name, scroll down, paste, public 2. Scroll up, copy the CIDR block, paste, and we'll just increment it. The availability zone, make sure you select a different one. If you select the 1A as well, we're going to run into issues. You have to select 1B, 1C, something else. It has to be different though. One more subnet. I'll explain why we're doing this in a second. Let's just create them first. Private -1. This can be the same availability zone as the public ones or different. You make that choice. For the CIDR block, let's copy, scroll down, and let's just increment. Great. They're all different CIDR blocks, all different names, and the two public ones are in different availability zones. Create subnets. Great. Now, jumping a little ahead, but why are we creating two public subnets? Because we're going to use what's called an application load balancer, ALB. This is going to be the entry point to our application. Previous videos, what was our entry point? It was the NGINX container. The ALB is going to be sitting in front of the NGINX container. Why do we use the ALB? Because this allows us to attach a Route 53 domain name to the ALB, so we can have our own custom domain name for our application. We're not going to go through Route 53 in this video series, but I do a previous video series on how to do that if you want to reference those. It also allows us to have auto-scaling, forwarding and trafficking rules, etc. Most of that is going to be handled by NGINX, but it's important that we have the load balancer in front as well. So now with that being said, here's our subnets. Bring this down. Now, again, why are we creating the private subnet and the public subnets? I'll just explain why we created the public subnets, why we need the private one. The private subnet is going to be used to put our ECS service inside of. We're going to put our ECS service in the private subnet because if something is in a private subnet, it cannot be accessed directly by the internet. That means it cannot accept unsolicited incoming traffic. We're going to put the private subnet, we're going to have the ECS service there. In the public subnets, we're going to have the NAT gateways. The NAT gateways are going to take requests from the ECS service, and the NAT gateway does not allow unsolicited inbound traffic, even though it's in the public subnet. So the NAT gateway is going to send the public subnet, and that's going to forward traffic to the internet gateway. And then from the internet gateway, that's going to go out directly to the internet. This was going to allow our application to access the internet while also securing it from unsolicited inbound requests. Okay, so that being said, let's keep going. Real quick, let's go to VPCs. I want to show you this because we're going to revisit this as we go and create the components, the resource map. Zoom out a little bit. Let's select the one we actually created. This is really helpful to visualize all the different networking components for our VPC. The VPC is the big container. Everything for our networking exists inside the VPC. So this resource map up here for our VPC shows how all the different components interact. We have a single route table. The route table tells us how we want to route our traffic for our different subnets to different components in our VPC. Right now, we have all of our subnets routing to the same route table, and the route table is not routing the traffic anywhere right now. This is a problem. We're going to fix that right now. First, though, we need to create what's called the NAT gateway. Again, the NAT gateway sits in the public subnet. And the public subnet is used to have the NAT gateway there so we can send traffic from the private subnet where the ECS service is to the public subnet to the NAT gateway, which can then go to the internet gateway and finally outbound. I'm repeating things a lot, I know, but that's because I want to make sure everything is very clear. Going back, here's our same prefix we're going to keep, and we'll just put NAT at the end. Common convention. The subnet, we're going to do the public subnet. Scrolling down, AWS Flask Celery subnet public 1. You do public 1 or public 2, we're just going to do public 1. If we want to be extra careful, we could create two NAT gateways, put one in each different public subnet. But for simplicity, we're only going to create the one NAT gateway and put in the one public subnet. We have to associate and allocate an elastic IP with it so it can connect to the public internet, and we can create it. Great, so NAT gateway is now pending and it's being created. Next, we can create the internet gateway. Going over here, this is the one just for the default VPC. You should see something like this as well. and we'll put the same prefix, and let's put IGW for Internet Gateway. Again, common convention, create, go back to Internet Gateways, and now we will attach to a VPC. Select our VPC, attach. Great. So now we have our Internet Gateway right here, and it's now attached. Let's go back to our NAT gateway and see if it's done creating yet. Still pending. We're going to give this a minute and wait for it to finish creating first, and then we'll move on to the route tables. Okay, once the NAT gateway is done creating, you see available right here. You can check the status by clicking this refresh right here and get the updated value. It should take around a minute or so. Once that's done creating, we now have the NAT gateway and the Internet gateway both created. Great. Now we can move on to our route tables. Here's the route table we care about right here. This is the main one. The main route table is the one we're going to use to route to our Internet gateway for our public subnets. So let's go ahead and rename this right here to make it easier to identify. This will be route table public, RT for route table. Save. Now let's edit the subnet associations. We're going to associate both of our public subnets. Great. That's done. Now we can go to our routes and edit the routes. This is the route for internal. So in any internal traffic, we're just going to route to local. But now, for any other traffic, we're going to route to the Internet gateway, which we already created. We can just select it right here. Great. Now by doing this, we've actually set that these subnets are now public. Just because we put -public right here didn't mean they were public. When we associate them with this route table that routes traffic to the Internet gateway, which is going to external rather than the NAT gateway, now they're designated as public. That's what actually makes them public subnets. Going on, now we need to create another route table. So we can create route table. We'll do route table private. Select the VPC, the one we already created. Great. Now if you're following along, what should we do here? We should first associate the private subnet that we created. Then we're going to do the same thing. Going back, here's private. We're going to go to routes, edit routes, add route 00, and route to now the NAT gateway that we just created. Save. Great. Go back to route tables. We now have two different route tables. One last thing, we can go back to our VPC. Now we can click into it and we see our resource map. This looks much more like what we want. Here's our public subnet. Here's our other public subnet, both routing to the route table public, which is forwarding traffic to the Internet gateway. And the private subnet is associated with the route table private, which is routing traffic to the NAT gateway. The NAT gateway sits in the public subnets, which then sends traffic to the Internet gateway. That's all the networking setup works. So now we're done creating the networking setup. We're now going to move on to creating the actual ECS components that we did in the previous video. In this video, the thing that's going to be different this time though is that we're going to use SSM Parameter Store instead of S3, and we're also going to have an application load balancer in front of our application rather than just using the DNS name provided by assigning a public IP to the ECS service, because the ECS service is no longer going to have a public IP. It's going to sit in the private subnet, so it's not going to be directly accessible. So we have to have that load balancer to give us the public DNS name to be able to access our application. So we're going to see all that right now. So the first thing we're going to create is the Elastic Container Repositories. This is where we're going to put our Docker images, which we're going to reference in our ECS Task Definition. So to start off, let's go to Elastic Container Registry. You can just search for it in the console and load it up. Once you have it, we're going to create two Elastic Container Repositories, one for NGINX and one for our Flask application. The Flask application Docker image is also going to be used for the Celery worker and the Celery beat task definition containers. Now you'll see here that I've already created the ECR repositories. We're going to see that a lot, that I've already created a lot of the components. The reason being is that unlike in previous videos where I created them all on the fly with you, is that this video series has a lot of different configuration components, NGINX, Celery, Flask, etc. that there's a lot of room for manual error if I don't create things exactly the right way. So I created them all from scratch first, and I'm going to have you follow along with what I've created and create them yourselves as we go through. So the first thing we want to do is create our two ECR repositories, as I've said. So create a repository. We're going to go to the same AWS ECS deploy.yml that we got everything from before and copy the names. ECS repository name NGINX. We're going to copy this, go here, paste, then create. I already have it. You can do the same thing for the ECR app. Just copy the name right here, create a repository, and put that name in there. Great. Now we want to actually push our Docker images to them. So let's do the Flask Celery ECR app first. View push commands. We're going to copy these and run them. First thing though, make sure you have Docker desktop running. If you don't, these commands will not work. So we have it right here. We're going to paste. Copy the next one, paste. And we're going to build a Docker image. Let that run. So it's done. Run the next command. We just tag the image. And we're going to finally push it to the ECR repository. Okay, once that's done pushing, we do the same thing for the other repository for NGINX. Now we're using two different repositories because the NGINX image is specific to NGINX. The other ones are agnostic to the Flask app, Celery Worker, and Celery Beat. This one, we have to do things a little differently though. So we can do the same thing here. We're already logged in. We just do run the command again if we want. Now we can't just use this docker build command as is. The reason being is because this defaults to the file name of Docker file. We have a separate Docker file just for NGINX right here. So you have to specify that with the -f flag. So going back right here, let's clear the console. We have this right here. We can do -f docker file underscore NGINX. Now this would be fine, except we also need to update our NGINX config. So go to the code first, NGINX config. We have to modify right here. We have to change this to localhost. Same with right here. Change from here to localhost. The reason being is that this is just how the ECS configuration works on AWS. You cannot use the container name, you have to use localhost. So there's two changes right there. We made those two changes. Now we can build our Docker image right here. Great, Docker image is built. Go back, we can tag it. And finally, we can push it. Great, all done. Clear the console, and we're back to here. Okay, just create our two ECR repositories that hold our Docker images. Now we can move on to our ECS Task Definition, which is just Elastic Container Service. You can type in the search bar and load it up fine. Now, for the task definition and the ECS service in general, let's explain the top-down components. We have the cluster, the ECS cluster, which contains ECS services, which contains ECS task definitions, which each ECS task definition you can specify one or more Docker containers, where each one of those Docker containers can either point to a Docker image in your Elastic Container repository. Here for NGINX, you just specify it right here, copy the URI, or we can specify a Docker image directly from the public Docker Hub, which is what we're going to use for RabbitMQ, Celery Flower, etc. Okay, let's now create our task definition. We're going to task definitions on the left. Zoom in a little bit, make it a little easier to read. Now, like I said before, I already have the components created, and you're going to follow along with what I'm doing. Now I'm going to create a new revision. You would click Create New Task Definition, and you would copy the name directly from right here. We would highlight this, and this would be the name of your task definition. Going back, undo a new revision. Okay, you paste the task definition name right there. Great. Make sure you select Fargate. We're going to use Fargate, not EC2, because Fargate abstracts away a lot of the infrastructure requirements and upkeep from us. We're good developers here. We're not systems engineers, so we're going to do Fargate. Make our lives easier. Linux, CPU, memory, no big deal. Here's one thing we do need to update is this task execution rule. This task execution rule, we're going to need to give access to the SSM parameters. That's the alternative FS3 we're doing in this video series, but we're going to save that until we actually create our SSM parameters a little bit later. So we're going to come back to this, but so we have it in the tab. Let's open up IAM. You can do a new tab and open up the IAM console, and we'll come back to this in a second. Scrolling down, let's create our first container. It's just going to be NGINX. So where are we getting our container name from? We're pulling it from here again. Here's NGINX. We're going to create our first container, NGINX. The URI is going to come from the repository right here. We copy the URI. In latest, we're in the Flask Celery ECR NGINX repository. I'm just going to paste it. Essential container, yes. We're going to do them all as essential containers, basically meaning that if a container is marked as essential and it fails, the entire service should fail. In reality, Celery B and Celery Flower aren't actually essential. You can turn those off if you want, set them to no. We're going to leave them all as yes for this video series. The container port is 80. Protocol TCP, they're all going to be TCP. They're all going to be app protocol HTTP, and the port name is always going to be the same as the container name. This is just a choice. You can make it different if you want. The container port is 80. What's an easy way to get all the ports for all the different containers we're going to be doing in this video? From the Docker Compose. I specified them all in here. RapidMQ 5672. Scroll down to NGINX, port 80, 8080. But that's just for reference. Minimize this, minimize this. The real truth comes from this NGINX config. We're listening on port 80. This has to match. If this is different, your application will not work. NGINX will fail as an entry point. So it has to match that 80, which we have here. Scrolling down, we don't have any environment variables for NGINX. No need. Make sure you do have log collection enabled. You should have this enabled for every single container in this task definition. What does this do? This provides you logs telling you why that specific container failed. If you're launching this ECS service, you're following this video series and you run into an issue, if you have log collection turned on, you can see why a specific container failed and troubleshoot. If you don't, you have no information other than the service failed. You can actually dive into what happened. So I always recommend turning this on for every single container. Going down, nothing else to configure here, we're good. Next, we have the Flask app. Where are we getting the name from? aws-ecs-deploy.yml, right here. Flask app, and we just copy paste. The URI, go back to our repositories. Now we're in this one. The latest, copy the URI, paste. Essential container, yes. Container port 5000, same as all for the Flask. TCP, Flask app, same. HTTP. Again, 5000, you can reference it from Docker Compose if you want. Scrolling down. Now we have all of our environment variables. Let me push this to the left. Now we can see things a little easier. Let me zoom out just a little bit so we can read things a little bit better. And we see we have 9 different options. And we see we have 9 different SSM parameter values, 9 different environment variables. Each one of these matches exactly what we have in our your.env file. The names are exactly as is. Why is that? Because that allows us to access them directly as is with this os.environment call right here for the Celery broker URL, for example. If we didn't have it like this, then we'd have to write custom code to access the SSM Parameter Store. Yes, this is very doable, but why make our life a little harder? Why we have to write 2 different versions of code, whether we're testing locally or on AWS? Why not have it all be the same? So we make our lives a lot easier by doing it like this. So let's zoom in a little bit so we can read things a little better. So we have our key right here, the Celery broker URL, which we just saw is the same as right here. This is how we want to make sure we specify everything. All of our keys right here should match exactly as they are in the your.env file. The value from is going to reference a value in SSM Parameter Store. So let's see that now. What you want to search for in the search bar is Systems Manager. Once you open this up, you look down on the left, scroll down, look for Application Tools, Parameter Store, and click into that. Now, as I said before, we're going to have 9 different values. Zooming out just a little. Celery broker URL, task result expire, app path, Flask config, secret key, and the 4 mail configurations. This is 3, this is 6, this is 9. These are all the ones you need to specify. I'm not going to go through specifying each one, but I am going to show you how to specify 2 of them specifically, and then you can pause the video and do the rest. Let's first do the Celery broker URL. Click into it. Or actually, we don't need to. We're just going to create it ourselves. Now, we're going to specify with Flask Celery as the prefix. Now, you might be asking, why aren't we doing AWS Flask Celery like we've been doing in this entire video series? Because with SSM Parameter Store, you can't prefix with AWS. That's why we're just doing Flask Celery. You can do something different here if you want, but I provide you the JSON policy for the IAM role that we have to update to actually permission access to these values. So I recommend doing exactly what I'm doing, but you can change it if you want. So Flask Celery, we're going to type in the Celery broker URL. Where are we going to get that value from? Directly from our your.env file. So we can paste it in here. and give it a value, string, and which value do we want to give it. I specifically chose this one because I want to make sure you're picking the right one. You don't want to do the one running locally with Docker. This will fail. You want to do the one running on AWS Fargate service. That's why you would copy this one right here, copy the value, and then paste it in. You click create parameter. I already have mine created. Great, so you have that one. Now you want to create the other 9. But real quick before you do, we notice that 2 of these are set as secure strings. Why is that? Because we want the value to be encrypted. So let's do an example with the Flask secret key. Or actually, let's do the mail password. This is a little more realistic. Create password, or create parameter, I mean. We're going to do the same prefix, Flask, Celery. And we're going to get the value for mail app password. Paste this in. Great. Scroll down, you can select secure string. And it's going to be secured by the KMS key, the key management service provided by AWS key for this account. Or you can specify a different one if you want. Put in the value. If you don't have this app password already set, refer back to the previous videos. You can set it from going right here to get your app password to be able to use your email to send. And you just put it in here. Let's put some random garbage. You put it in, and then you see it obfuscates it for us. Click cancel because I already created it, and then you would have 2 different parameters created. You need to fill in the other 7. So go ahead and pause the video right now and type in those 7 values. Okay, so that's SSM Parameter Store. Now we can go back. Now we can actually type and paste each one of these values in. Again, the same 9. You can copy them directly as they are named. We use the same names here. They could be different, but we're doing this to make it easier to identify. But they do have to match these keys. You have to match exactly what you have in the your.env file. Mail out password, all caps, mail username. So we can reference them in here. If they're different, they won't be able to reference an os.environment will fail because it won't be able to find the value. And make sure you select value from. If you select value, it will actually treat this directly as is. It will treat the Celery broker URL as this string rather than trying to pull it from SSM Parameter Store. So we do this, all 9 of these for the Flask app container. Real quick though, remember what I mentioned before, if you scroll up, for the ECS Task Execution role, we need to give access to these SSM parameters after we create them. So what do we do now? We go to the dashboard for IAM. You can just search for IAM up here. On the left, we're going to select roles. And we're going to search for this ECS Task Execution role. So we can type ECS, and we have it right here. We can create a new one if you wanted to. We're just going to use the existing one as is. And what you're going to add is you're going to add this one right here. You're going to grant access, the SSM get parameter access to the SSM parameters with the prefix Flask Celery. This /* means you give access to all of them underneath this top level path. In System Manager, going back to Parameter Store, we already have it here. All of them are prefixed the same way, which makes it much easier to assign access in IAM. Now, if you want to add this IAM policy easily, you don't have to pause the video and type each one of these in manually. You can just go to right here, underneath the top level directory, AWS files, IAM policy SSM access. You can copy this right here. We're going to do add permission, create inline policy. We're going to do JSON and then copy paste. And you can just replace this account ID with whatever your account ID is. And if you change the prefix, make sure you change it here as well. You click next, you give it a name, and you click save. And then you have the ECS Task Execution role to have access to your SSM parameters. So this Elastic Container Service is going to be able to access your SSM parameters, which is exactly what you want. Great. That's our ECS Task Execution role. So going back, we already created our NGINX container. We're midway through our Flask app. We already have this defined. We defined all of our SSM parameters. Great. Our ECS Task Execution role now has access to our SSM parameters. Keep going. Use log collection. We should always enable this by default. And the Docker configuration. This is the command we need to run this specific container. I want to put it in Notepad so it's easy for you to copy. Go ahead and pause the video, copy this down, or you can copy it directly from Docker Compose and remove the quotations and put it all in a single line. Okay, you put it in there, and then we're good with that one. Next, we can do RabbitMQ. Where do we get the container name from? Going back, aws-ecs-deploy.yml. Here's our container name. You can copy paste. Image URI, you can just type this exactly as is. Search for container, yes. Container port 5672. Get it from Docker Compose if you want. or you can just copy directly as is, as you see on the screen. TCP, same name, HTTP. Great. No environment variables needed. Make sure you use log collection, and no Docker configuration necessary either. Going down, next container name, back to here, Celery worker, copy paste, image URI, container registry, same URI, ECR app, copy paste, essential container, yes. Scrolling down, no port mappings required, and we have all 9 SSM parameter values again. So if you already have it in the Flask app, you can copy and paste directly from there, or you can type them in again if you want. Now again, where do you get this value from exactly? Going back to the SSM parameters, Celery broker URL, you click into here, and you copy and paste this ARN value right here. Unfortunately, you have to click into each one, and you paste right there. Great. Going on. Logging's enabled. Great. And then Docker configuration. Here's our big long command. Again, you can copy this directly from docker compose.yml, removing the quotes and the new lines, or you can pause the video right now, copy this, and then paste it into here. Okay, that's our Docker command. Next, we have Celery beat. Essential container, yes, not actually necessary. Last container registry, same URI, copy paste. Where's the name coming from? Container name, same as all the other ones, nothing special. Copy paste, scrolling down, no port mappings. We only need these 5 SSM parameter values, so you can copy and paste these. Make sure you just have these 5. Scrolling down, logging is enabled. Docker configuration, much shorter this time. Put it right here. You can pause the video, copy this, and then paste it into there. Scrolling down. Last one we have is Celery flower. Here's the name. Copy paste. Docker image URI is coming from Docker Hub. Same thing we're doing for RabbitMQ. You can type this exactly as is, you see on the screen. Essential container, yes. Not actually necessary, you can set it to no. Container port 5555. You get it from Docker Compose, but even more important, as well as for the Flask container, is it has to match this port right here. Otherwise, the NGINX container will fail to route traffic correctly to the Flask container right here, and it will fail to route traffic to the Celery flower container right here. This 5000 has to match the port mapping on the Flask container, and this 5555 has to match the port mapping on the Celery flower container, which we see right here. Celery flower, port 5555, Celery flower, essential container, yes. Scrolling down, we only need 2 values right here. Celery task result, expire seconds, Celery broker URL, great. Use log collection, and then Docker configuration. Here's the command. I'll put it in Notepad real fast. Pause the video, type it down, and then paste it in there, or you can get it from Docker Compose. Real quick, this value would have to change if you wanted to use Redis instead. Just take that in mind. Okay? That's all the different containers, and now we're done. So what do we do specifically? Let's go up to the one with 5 real quick. We took using an environment file. We were using an S3 bucket. We had all our values there. Instead, we used SSM Parameter Store. Why is that? Because S3 bucket, we couldn't use secure strings for something like, going back real fast, something like the mail app password. It wasn't secured right here. Meaning that anyone who accessed the S3 bucket immediately got to see the plain text password, which is bad because an app password for our email account gives unfettered access to run applications with our email credentials. So we don't want that. We want to specify them in these SSM parameter stores. App path, config, secret key. Now you might make the fair criticism, okay, then why do we put Flask app path, Flask config, Flask secret key in something like SSM parameter store? These are just plain text strings, something like production or the app to the Flask application. Why put them there? Why not hardcode them in the application? Why not put them just in the S3 bucket and use that instead? You could absolutely use the S3 bucket. You could also hardcode them in the application. The reason I put them in SSM parameter store is to keep all the environment variables localized to one location. So if you need to make a configuration change to any of these variables, you make them in one location, and then it flows through to all of the containers. It simplifies any kind of updates you want to make, and also follows the principle of don't repeat yourself dry. You want to always emphasize this as much as you can, even in these networking setups. Okay, so once you've done all of that, you can click Create, and then you'll have your task definition created. Great. What's next? We can go back to Elastic Container Service. We can now create our cluster. Where's the cluster name coming from? Same file, aws-ecs-deploy.yml. Here's our cluster name. Copy this. Paste. No namespace. Same as what it is. Fargate. Again, same as the task definition. Has to be the same. We're going to turn them off. We don't actually need container insights here. Okay. We're going to give this about 10 seconds. It doesn't take too long to create the cluster, thankfully. It's pretty quick. Keep refreshing. And there it is. Great. We have the cluster. What can we do next? We can move on to the service. We're just going to do launch type because we don't actually need something like the capacity provider. What does this do? This provides scaling up the instances of our app and scaling down based on incoming traffic. We're doing a very small example here. We're not going to dive into those specifics. This is much more advanced concept. You can look into this if you want. It's going to be a service, task definition family, the one we just created. There we go. It automatically selects the latest version. Service name. Where is this coming from? Coming from the same file right here. Service name. Make sure you get the E2 and you can paste it. Great. All right. We don't need to worry about any of that. Service connect. Nope. Here's where the change happens. The networking. We're no longer relying on the default. We're using the one we just created. And we're no longer using all the subnets. We're only going to put it in the private subnet, just like I mentioned previously in the video series. We'll rely on the default security group because this security group created specifically for the VPC we just created. So there's not really a problem in using this. Public IP will turn it off. This is production ready. This is what we should do in every production instance. Scrolling down, we also want to add load balancing for an application load balancer. Because remember, our NGINX is no longer going to be the entry point. Our ECS service is no longer going to have a public IP attached. We can't just go to the public IP of the ECS service. We need an application load balancer in front to be able to access our application. So we have to create one. Now, we're going to try to create one here, except it's going to fail. Why is that? Because an application load balancer, like I said previously, we were creating the subnets. You need 2 public subnets in 2 different availability zones. We're creating this ECS service. We're only assigning it in the private subnet, so it's going to fail. This is wrong. So we need to create the application load balancer actually outside of it. So let's go to EC2. So you're going to load the console, scroll down the left, and go down to load balancers. Click into it. And now we're going to create our load balancer. Currently we have 0. Create load balancer. We're going to make sure we select application load balancer. Load balancer name. This isn't actually important, but we're going to use the same prefix. Again, make everything easily to identify. AWS Celery, and we're just going to do -ALB, industry standard. Internet facing, yes, because we want to access the internet. It's not going to just be internal. IPv4, yes. VPC, the one we just created. Availability zones, we see the 2 that we created that are both public. They're both routing to the internet gateway. We notice that we don't see the private subnet here. It's not even an option because it has to map to the public subnets. Security group, we're going to use the default one that's assigned to our VPC. No problem there. Now we need a target group. We don't have one, so we have to create one. Let's go ahead. Click the link. It launches scroll down the left, we'll see exactly what it launches. It launches this target group section right here. We're going to do IP addresses because we're using Fargate. Every time Fargate spins up a new instance, it's going to assign a random IP. So we're going to do assignment based on IP addresses. Scrolling down, target group name, same prefix, -TG. Great. 80 is our port. That's fine because we're using NGINX. Entry point is port 80. VPC is correct. And nothing else to do. One caveat, if your health check, your root directory is password protected. Say your entry point was the Celery Flower dashboard and you had a username password requirement. It would fail. You have to have an entry point that is accessible without a username password requirement. Otherwise, it may fail the health checks. Just one thing to caveat, probably not going to come up, but for the few that need it, I just wanted to mention it real quick. Nothing to do. We're not assigning any targets. Why? Because we're going to have targets automatically assigned when we create the ECS service. There's no ECS service created yet, so we don't actually have to assign anything. So what's going on with the target group? This target group has no registered targets. Once the ECS service is created, it will automatically register a target. So what's happening? Go back to the application load balancer, refresh real quick. We assign it. That's our listener. Scrolling down, we're going to ignore all the rest, and we're going to create it. Great. load balancers, and we see it's provisioning. So like I just said, what is happening? The ALB is going to give us a DNS A record. This is going to be an entry point of our application. This is it right here. We're going to put this in the browser. We're going to click enter, and we're going to be able to access our application and see the hello world index route. Great. How does it know to do that? Because the application load balancer has a rule and listener on port 80, which is what we're going to access our DNS A name from, is on port 80. When we hit port 80 for the DNS A record, it's going to forward to the target group, the one we just created right here. And what does the target group do? It registers targets to send traffic to. What's the register target going to be? It's going to be the ECS service containers that we have, the NGINX one specifically. Great. So let's go back to our load balancer. Let's see if it's done provisioning. All right, so we're going to take a second and just wait for this to finish provisioning and then pick back up. All right, it's done creating. You can see here by the active. Just keep refreshing. Just take around a minute or two. After that's done, we can go back to our service. Now we can actually use our application load balancer. One thing though, it's not going to show up initially, so we're going to have to refresh and redo this. Again, we only did a few things for the service though, so it's not a big ask. Just click the F5, refresh, going down, capacity provider Fargate, service, task definition name, right here, revision latest. Where's the name? We're getting from right here. Copy, paste, great. Ignore the rest. Networking, again, the Flask Celery VPC. Scroll down, we only want the private subnet. Good. Existing security group, the one defined for our VPC we just created, no problem there. Turn off the public IP. Load balancing, yes, we've just created it. Application load balancer. NGINX, this is the port we want to see. Use existing, and the one we just created, great. Use an existing listener, 80. And use an existing target group, right there. Great, everything's good, create. All right, we're gonna let that run for a sec. Go back to our services, we see down here, refresh, we see it's now created. And what's going to be doing right now is going to spinning up the task. So click task, you see none right here, it's gonna be spinning them up. Now, real quick, if you run into issues here where it's failing for any reason, what I recommend is going to logs, and by default, it says any container. When the task starts spinning up, give a refresh, see if it's there yet. Right here, it will show each one of the tasks. If you select it, zoom out just a little bit, so you see everything a little better. Here you select your task, you scroll down, you can see each one of the individual containers with a status. It will show you which one failed. And once you see that, you can go into the logs and pick which container you want to see the logs for, because you're not concerned with Celery beat if there was no failure for the container. If the Flask app is having the failure, you want to click into that one specifically, see the logs, and see why it's failing. That's the power of having that logs collection enabled for each one of the containers in the task definition that I mentioned previously. Let's give a little refresh right here. We see all the containers are running successfully. Great. What's next? Go back to our load balancer. Let's click into it. Zoom in a little bit so it's easier to read. One more. Move it up. Go down. So we're in the details section of the load balancer. Here's our DNS name, and we're going to go right here, paste it, and we should be able to access it. Now I'm going to go back to the first question I asked initially in this video is, why is this going to fail? Specifically related to the VPC security group. Why are we not going to be able to access this application? It's because we don't have port 80 allowed on our incoming IP. Let's try to access this. It's just going to spin, and eventually say it can't resolve. What do we need to do? We need to go to our security groups. So we see right here, we're in the VPC console. We want to security groups. We want the security group specifically related to our VPC. Now we need to find the actual security group ID for the VPC ID that we need. Let's go back to the VPC console, because it doesn't actually give us a name for the VPC when we do that, unfortunately. Scrolling down, here's the ending in 822D. This is the one we want. So let's go ahead and copy this. Go back to the security group, 822D. That's this one right here at the bottom. So we can click this and edit this so we can make sure it's easier to find next time. You see how powerful this can be, and you see how annoying it can be if we don't use any kind of naming conventions. And inbound rules. We're just going to edit our inbound rules. By default, it allows all traffic within itself. You just want to add a role, custom TCP, port 80, and you want to do my IP. I'm not going to do that because I don't want to expose my personal IP. You absolutely should not do anywhere though. You should do my IP. And port 80 because NGINX is our entry point. And also we're running the application load balancer listening on port 80. So save rules. Great. We're here. Can't be reached. And it automatically refreshed for us. Great. Let's go to the Flower dashboard. See if we can see everything. Here we go. Here's our worker. Quick refresh. We see our tasks that are running. We see 12 for test print, which is just a Celery beat running every 10 seconds. Great. Now let's go back. Let's try to send an email. This is the true test of Celery. Here's our recipient, test, and test. Send email, send an email. I can check this myself in my email inbox if I want to. I also go to Flower and see our task. Give it a quick refresh. And we see send async email, sent one successfully. Great. So we know that it worked. Go ahead and close this, and we're all set. All right. So this is our DNS name, again, for the AWS Flask Celery application load balancer. It's how we access our application. If you wanted to, you could extend this and go to Route 53, direct traffic to the application load balancer for your custom domain name that you own, and then you would have a fully functional app with a real domain name. That'd be great. I'm not going to go through it in this video, but I have gone through it in previous video series how to set that up, and you can follow along with those if you want. So that's how you create a production-ready app with NGINX, Flask, and Celery on AWS, also with Celery Flower and Celery Beat. Now let's do a quick recap of what we did to make this app production-ready versus the previous video's Get It Working app. We replaced S3 with SSM Parameter Store. We secured the environment variables so they're not able to be stored in plain text in S3 to make it more secure and production-ready app. We also use a networking setup instead of relying on the default ones provided by AWS. We took off the public IP assigned to our ECS service to allow it to be publicly accessible on an IP. Instead, we turned that off and put it in a private subnet. We use networking setup so that can exist in a private subnet and still access the outgoing internet by putting a NAT gateway, internet gateway, and an application load balancer in front of it so traffic can still come to it while it can still be protected. And again, that ALB entry point can be expanded upon with Route 53 if you so desire. One thing I won't cover here is how to use Redis as well. I mentioned it previously in the previous video as well. We went back to Elastic Container Service and went to the task definition. You could select the one you just created, create a new revision, and you would just want to replace that RabbitMQ container with the Redis one. So we can minimize this. We want to modify it here. We'd also want to modify going down to Celery Flower. It's at the bottom. We'd want to modify the broker right here. In addition to that, we'd also have to modify the SSM parameters for the Celery broker URL, where we want to select from right here. Again, these are for AWS Fargate service. This is for local. These two are different. As you see, localhost right here and Redis right here. So you have to make sure you select this one right here to run on AWS Fargate if you want to use Redis instead of RabbitMQ. So those are the changes you'd have to make. I'm not going to go through them in this video per se because it's just too much time, but it's pretty simple enough to do it. It's just a few different configuration changes. Okay, so I hope you learned a lot in this video. Again, I really appreciate any kind of help you could give me by subscribing, liking the video, Patreon, GitHub sponsors, sponsoring me. It means a lot. I really appreciate it. And if you are getting a lot from these videos, I do appreciate hearing about that. Send me an email. Let me know how you're using this in your firm, how much help you're getting from it, how you're implementing it. This does make me feel very fulfilled to know that people are using the videos that I'm putting out rather than just seeing faceless statistics on YouTube stats saying your video has been watched this many times this week or you got a certain number of likes. Seeing those responses really does invigorate me and makes me feel fulfilled that what I'm doing is actually helping people. Because yes, I would like to make some kind of monetary gain from this because of the amount of time I'm putting in, but hearing from your guys' stories and your girls' stories, how you're actually benefiting, that is very fulfilling in its own right as well. Okay, with that being said, the next video, we're going to go through GitHub Actions. That's the continuous deployment CD section that I mentioned previously using this file, this ECS-deploy.yml. We've referenced this file a ton. I've talked about GitHub Actions. I've talked about CD. I haven't actually shown you anything to do with it. It's kind of this esoteric file where you're just copying and pasting from. No longer. Next video, we're actually see how these things actually work. We're going to become a power user and using GitHub Actions to automate the deployments and update of our application on AWS. It's going to be a very powerful video, very informative, very helpful. Highly recommend you watch it. So stay tuned for that one. If you have any comments or questions, leave them below. And yeah, hope you learned a lot. See you in the next one.